Okay, so since I wasn't there in class today, I'm just going to briefly go through the notes that we already talked about, and then also go through the ones that we were going to do in class today, just as a review to help you guys in case you were a little bit confused or lost. So, here are the objectives for the chapter. The chapter test still will be on Friday. We'll do it at the end of the period on Friday, though. Alright, so what is physics? If you remember, physics is the basic science. I said that all the other physics, or all the other sciences can be built on physics. It's a study of natural world, study of energy and changes, and that's everything we'll be studying this year. So these are the 6 specialty areas. You do need to be familiar with the 6 and what they mean. So review these definitions for the test. Okay, the International System of Units. Remember, there are 7 different base units. We use them because all scientists throughout the world will also be using these systems, so that we can understand everybody's work throughout the world. You do need to be familiar with the base units, such as the meter, the kilogram, the second, the Kelvin, as you go into the test on Friday. Alright, the SI prefixes. Please remember that you do have to have this table memorized. So I would suggest maybe making flashcards for them or something so that you remember the prefix name, so this first column right here. Also the prefix symbol, the second column, and then the power of 10 is going to help you when you are converting between prefixes. Okay, so conversions using SI prefixes. We did this the other day in class. I think the easiest way to do this is to subtract the exponent. So to take the exponent of the given minus the exponent of the wanted, and that's from that prefix table on the previous page. The result, it tells you the direction to move the decimal, but also how many places you should use it. So if you get a positive number as a result, you move the decimal to the right. If you get a negative number, you move the decimal to the left. The number that you are given is going to be the number of places you move it. So for example, if I have 13,097 milligrams and I want to get it into kilograms, I'm not sure how many that is, I know the exponent for milli is -3, the exponent for kilo is +3, so if I subtract those, -3 minus a +3, I get -6 right here. The negative part of my answer says move it to the left. The 6 tells me to move it 6 spaces to the left. So I take the where the decimal is right now, which is at the end of the 7, I move it 1, 2, 3, 4, 5, 6 spots to the left. In that empty space I put a 0, so I get 0.013097 kilograms as my answer. Alright, accuracy versus precision. Remember, accurate is how close the measurement is to the true or actual value. So if I was measuring the length of a table, there is an actual measurement or an actual length. If I'm accurate, I'm getting really close to that number. If I'm precise, I can measure the table 5 different times and I'm getting numbers that are really close to each other. So my individual measurements are very close to one another. Okay, sig figs. The reason we do sig figs is so that we can show our certainty in our measurements. Each measurement should have 1 digit or 1 degree of uncertainty. So the last digit in your measurement should be an uncertain or a guess. So when you make a measurement, you need to write down exactly what you know, which in this case, I know 25 for sure. Now I know it's past 25.5. But I don't know how far past 25.5. Now I'm going to make a little educated guess on this next digit, and I'm going to say it's 25.7. Was that 7 a guess? Yes, it was, and so that last digit has to be a guess. I cannot add any more numbers to the end of this. I can't say, oh, it's 25.75, because that's as if I was lying to the people that look at this. I don't know that I don't know this 7 in the tens place for sure, and so I can't add another digit to the end of it. So my answer would be 25.7 centimeters. On this one, what is the volume of the graduated cylinder? So I'm measuring from the bottom, which is the meniscus. So if I draw it over, I'm looking at 44 for sure. I know that. Now my next digit that I'm going to add on here, I think it's maybe like 44.6. Was that 6 a guess? Yes, it was. And so that's the last digit that I can put on there. I cannot add any more digits past that one. Okay, now getting into rules of determining sig figs in different numbers. When we're looking at a measurement and I'm asking for how many sig figs does it have, sig fig stands for significant figure. When I say significant, it does not refer to the importance of the number. Okay, it's not saying these numbers are important but non-significant numbers are not important. It has to do with whether or not the person actually measured the number, or is it just there holding a place? Is it showing us where the decimal is? Any non-zero digit, looking at rule number 1, that's going to be 1 through 9, those are considered significant. Any zero that is between a non-zero digit, so between non-zero digits, those are also significant. So in this example, how many sig figs do I have? Well, that zero is in between two sig figs. So I have 1, 2, 3, 4, 5, 6 total sig figs in that number. Rule number 2, leading zeros are not significant. These 3 zeros at the very beginning of the number are leading zeros. Those 3 right there. The 3 and the 4 are non-zeros, so they are significant, but the 3 zeros are not, that are in the front. And so my total number of sig figs in this number is 2. Rule number 3, zeros to the right of all non-zero digits are only significant if the decimal is shown. Okay, in this example right here, those 2 zeros are to the right of all the other digits, but there's no decimal, so they do not count as significant. So there are 2 total sig figs here. What that means is someone put them there to as place value holders, not necessarily because they were measured. In this case, though, notice the difference is that I have 3,100.0 centimeters. The decimal is shown in this case, meaning that the person actually measured all 3 of those zeros, and they want you to know that by putting the decimal there. So in this case, those 3 zeros would be considered significant. So we have 5 total in this one. For rule number 4, for values written in scientific notation, the digits and the coefficient are significant. What that means is this number up here in the front, that's called the coefficient. Any numbers that you see there, even any of the zeros that are there, those are going to be considered significant. When you put something into scientific notation, if a zero is significant, then you need to include it in the coefficient. If it's not significant, then you don't include it in the coefficient. So I just count up the numbers in the coefficient. I have 5 of them, so there are 5 sig figs in this number. Okay, when we're doing calculations with sig figs, there are 2 different rules. There's an adding and subtracting rule, and then a multiplying and dividing rule. The adding and subtracting rule has to do with the precision of our measurements. When I talk about precision, I'm talking about the place value of the last significant digit. So you may want to add that to your notes. This is place value of last sig fig. So if we look at 49.183, the last sig fig is the 3 here. It is in the thousandths place. On 72.13, the last sig fig is also a 3. It's in the hundredths place. Which one is least precise? Which one is telling us less information? It's the one in the hundredths place. So when we get our answer, I plugged it into a calculator. You can see the answer gives us 115.313. Well, our answer has to match the precision of the least precise. Our least precise went to the hundredths place, so I rounded and put the answer in the hundredths place as well. When we are doing multiplication or division with sig figs, the rule is that we have to look at total number of sig figs. So our answer will have the same number of sig figs as the measurement with the least number of sig figs. So if I look at my 2 numbers, 3.425 and 23, 3.425 has 4 sig figs. 23 has 2 sig figs. 23 has less sig figs, so our answer has to match that. So if I plug this into a calculator, you get 78.775. I need it to only have 2 sig figs to match the 23, which has the least number of sig figs, and so I round it to 79 meters squared. All right, when we are doing calculations where we have both, we might have an adding and subtracting or a multiplying dividing in the same problem, a combination. We're going to use order of operations, just like you would in math class. So the PEMDAS, which is parentheses, exponents, multiplication, division, adding, subtracting. After each calculation that we do, we have to apply the correct sig fig rule. So you can see over here on the right that if I plug this into a calculator, I get 617.21. Okay, that would be if we are not paying attention to sig figs at all. So if these weren't measurements, they were just numbers. So because these are measurements, though, we need to apply our correct sig fig rules. So the first thing we do is parentheses. So we add 3.4 plus 4.32 plus 10. We get 17.72. So if we look at the three numbers, the adding subtracting rule, if you remember, is the least precise. So if we look here at 3.4, that is in the tens place, that 4. The last sig fig in the 4.32 is in the hundredths place. And then the last sig fig in the 10 is actually in the tens place. And this is where I went wrong on this. I messed up as we go to the next step. So I'll fix that as we go along. So I need to keep to the tens place only. So this number right here, rounded to the tens place, should actually be 20, not 18 as I have in the notes. So we'll cross that out and say no. So we have 20 meters. Now our next thing that we are going to do is multiply. So we have 20 times 33. So let me calculate that real quick. 20 times 33 is 660, so we'll cross that out because that's wrong. So we get 660 as our answer for 20 times 33. Now, with our multiplication rule, we have to keep the least number of sig figs. So 20 has 1 sig fig, 33 has 2 sig figs. So we can only keep 1 sig fig in our answer. So 660 rounded to 1 sig fig, cross out the 590 because that's not what it should be. 660 rounded to 1 sig fig should be 700. Okay, so now our last step was to do this last adding, so 700 plus 32.45. We'll cross that out because that's wrong. That's going to be wrong too. So we get 732.45. If you were to plug into your calculator, well, with our adding rule, we have to keep to the least precise. So our 700, that is in the hundredths place. And our last sig fig in the 32.45 is in the hundredths place. Which one is the least precise? Well, it was the 700 going to the hundredths place. So if I round my answer to the hundredths place, I actually just end up with 700 meters squared. Okay, so notice that your answer is actually quite different than the one you would have gotten if you had just plugged into the calculator. But it's very important that we keep track of these sig figs because each measurement has a little bit of uncertainty or a guess to it. If we were to write the 617.21 as our answer instead, we're saying that we know every single number in there, and we don't. The last digit, remember, is always a guess in our measurements. Okay, converting to and from scientific notation. So hopefully this is all just a quick review of scientific notation. In order to go to scientific notation, you need a coefficient that is between 1 and 10. So you need to move the decimal over until you get a number between 1 and 10. The number of places you have to move the decimal becomes the power of 10, or the exponent. If the original number was greater than 1, then the power of 10 is positive. If the original number was less than 1, then the power of 10 is negative. So if we look at this first one, I need to move the decimal over 2 spots in order to get it in between a 1 and a 10. And then what I have left is 3.8590. I have to include that last 0 right here in my coefficient because it is significant right here in the original number. So I need to also include the power of 10, so I have 3.8590 times 10. I moved the decimal 2 spots, and the number was originally less than 1, so it's a negative 2. And then my meters, my units, goes at the very end there. A lot of people tend to put their units right here instead, in between. Please do not do that. That's incorrect. Make sure that you put it at the very end. Okay, now if I'm going back from scientific notation to conventional notation, I'm going to look at the exponent. The exponent, whether it's positive or negative, tells me which way to move the decimal. In this case, it's a positive 5, so I'm going to move the decimal to the right because the original number was bigger than 1. So I move it 5 spots. In those blank spots, I put zeros, so I should have 4 zeros off the end. And then meters, so 650,000 meters. Okay, and then lastly, dimensional analysis is a way that we use in physics to analyze units. It's really how we solve problems, and I think it's the easiest way to solve problems because you know what's happening with your units before you do any calculations, and that's very important in our physics classes, to keep track of your units, to know what your numbers are meaning. So I call this thing right here a train tracks. Really, it's just to hold a conversion factor. A conversion factor might be something as simple as 1 foot equals 12 inches, or 100 centimeters equals 1 meter. They're just two things that are equal. Now, in my conversion factor, in my train track, I'm going to put this conversion factor. It doesn't matter which way I put it. I could put 1 foot on the top, 12 inches on the bottom, or I could switch it and put 12 inches on the top and 1 foot on the bottom. It just depends how I need it. And you will know that based on what units you're trying to get to. So, and one thing that I saw when I was looking at practice problems for this is there was a teacher who said he puts on top, this is what you want on top, and it is going to be over what you've got on the bottom. Okay, so you're always trying to cancel out units, and so you put what you've got on the bottom and what you want on the top, and that will help you get more units for that. Okay, so let's do a quick example with the dimensional analysis. So the example that was in the Nearpod had to do with, you have a bunch of pennies, or you found a bunch of pennies, and it wants to know how much money was that worth. So let's do that example right here. So you have, I'm trying to find it here. Let's say that you have, for example, you found 3,215,100 pennies. Okay, and you want to know how many dollars is that? So we know that there are 100 pennies in a dollar. Okay, so if I'm going to set up a dimensional analysis, I'm going to do 3,215,100 pennies. I draw my little train tracks. Okay, I want dollars, so I put dollars on top. I got pennies, so I put pennies on the bottom because I want them to cancel. I know that there are 100 pennies in $1. Notice my pennies units cancels and I'm left with dollars. So what this gives me is this $32,151. Okay, so that would be the way to solve the first part of it. But then the second question was, if each penny weighs, I think it said 4 grams, how many pounds was all of this loot? Okay, so we can't go directly from pennies to pounds. but they tell us the conversion factor of each penny is 4 grams. So I put what I want on top, which is grams, and I put what I've got on the bottom, which is pennies. I know that 1 penny is 4 grams. Notice my pennies unit cancels. Okay, now what I was given that 2.2 pounds equals 1 kilogram. I can't go directly from grams to pounds, so I'm going to go from grams to kilograms because I know that conversion. So I put what I want on top, kilograms. I put what I've got on the bottom, grams. And I know that 1 kilogram equals 1,000 grams. That's according to that SI prefix chart that I have and that I want you guys to memorize. So the grams cancels. Okay, now I have kilograms. Well, I was given the conversion that kilograms, 1 kilogram equals 2.2 pounds. So I put what I want on top, pounds, what I've got on the bottom, kilograms. So 1 kilogram equals 2.2 pounds. My kilograms cancels. Now, this is the dimensional analysis part. So I analyze the units. Notice all the units have canceled. The pennies canceled, the grams canceled, the kilograms canceled. I'm left with pounds. That is what I want. That's what the question is asking. So I'm going to put my equals sign and go ahead and solve. So I have, I'm going to multiply everything that's on the top. So 3,215,100 times 4 times 1 times 2.2. And then I'm going to divide by whatever's on the bottom, which is 1,000. So that answer divided by 1,000. And I get 28,292.88 pounds. And that would be the answer for that. Okay, and then finally, just updated schedule for the rest of the week, just so you guys know exactly what's happening. I should be back on Wednesday. So what we'll do on Wednesday is we will go over any questions you have on the homework. Okay, so please start the homework and be prepared with questions that you have. The homework will be due on Friday at the beginning of class. We will correct it in class together and then go over any extra questions that you might have over that homework. Then the quiz that is scheduled for Wednesday, we will still have it at the end of class on Wednesday. What that is over is the converting using that prefix chart. You do not have to have it memorized by Wednesday. You'll need to have it memorized for Friday's test. But I will have it on the board posted so that you can see it ahead of you. So be sure that you can convert between those prefixes using that method of subtracting the exponents and then moving the decimal. The other thing that's going to be on there is calculating using sig figs. So make sure that you know you'll have to know the multiplication division rule and then the adding subtracting rule and be able to perform a calculation and then apply that sig fig rule to it. For review for the test, the review is posted on Edmodo already, so please go there, find it. You could start reviewing if you would like to. We will have some review time on Wednesday, and then also the beginning half of the class period on Friday will be a review after we correct the homework. The test for this unit is going to be at the end of the period on Friday. So hopefully with answering any questions on the homework on Wednesday that you have, correcting the homework on Friday, going over it again, the review being on Edmodo, and then going through some of it Wednesday, and also before the test on Friday, you'll be prepared for the test at the end of the period Friday. If you are struggling with any of this stuff, and you need to talk to me before, before we get to that test on Friday, please be proactive. Email me, set up a time that we can meet. I can meet usually before school. I could also do at the end of the lunch period, but please just email me or contact me, come see me so that we can set up a time that you can come in and have your questions answered if you have any.